So let's say that you have an equation, a quadratic equation that perhaps isn't in this nice ax squared plus bx plus c form, but you'd like to solve for x. So let's say we got some, ugly looking thing like this guy, okay? 2/3 x squared plus 1 equals 5/6x. So let's say you have something that looks like this. And I can use the quadratic formula here to solve this. But I have to make sure, because remember the quadratic formula says that x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And let's just recall that a, b, and c are your coefficients that are attached to your variables, and also c is just your constant. So a x squared plus bx plus c equals 0. This is the form that we want. And then as soon as I can spot what a, b, and c is here, then I can substitute it back into my equation and solve for x. So when I look at this equation, what I started with here, this doesn't really look like ax squared plus bx plus c. So I just need to rearrange this equation so that it takes on this form. So the first thing I'm going to do is I'm going to move everything to the left-hand side and have 0 on the other side. So this term 5/6 times x, I want to push that over to this side because I just need everything to be on one side of the equal sign. That's all. So I'm going to rewrite this as 2/3x squared, but I'm going to go minus 5/6x plus 1 equals 0. Okay, and then if you notice, what else is sort of in my way, what's not looking totally proper here, is these fractions. I'm not feeling it, the 3 and the 6. And then this will just be a ninja 1. So what I'm going to do is I'm going to create a common denominator so that I can cancel out these denominators. My lowest common denominator between 1, 3, and 6 is going to be the number 6. So I'm going to rewrite this. So I'll have times 2 times 2. I don't need to do anything to the middle term. I'll have to multiply 1 by 6 as well. So then my equation starts taking on, it starts looking like this. It'll be 4x squared minus 5x plus 6. And then because I'm dividing now every single term by 6, that means the whole entire expression is being divided by 6. And last but not least, in my final step, I want to get rid of this 6. So what I'm actually going to do is I'm going to multiply everything on this side by 6. And then I'm going to multiply everything on this side by 6. This will cancel on the left-hand side. And on the right-hand side, I have 0 times 6, which is just 0 anyways, right? So I'm going to be left with 4x squared minus 5x plus 6 equals 0. So there's my equation. So this is what I started with, this ugly looking thing, right? And I rearranged it so that it would look, it would take on this form of ax squared plus bx plus c equals 0. And now I have something where I can really easily identify what that a, b, and c value is, right? So in this case, a is equal to 4, b is equal to, again, I got to count for that negative, that's negative 5, and c is equal to positive 6. And I'm going to substitute those numbers into my quadratic equation. So it's going to look like this. So what I'm doing is I'm just placing brackets everywhere so you can see which numbers I'm about to slide in. So a equals 4, b equals, so I'm going to have negative b, so that'll be negative 5, plus or minus the square root of b squared, so that'll be negative 5 squared. And then that's all going to be over 2 times some a value. Okay. So this will be 4 times AC. So that'll be 4 times a, which is 4, and then 6, that's C, and then 2 times a, which is 4. So your quadratic formula, or your formula here, it's going to, when we clean it up, it's going to start looking like this. It'll be positive 5 plus or minus the square root of 25. Take away. Now 4 times 4 times 6 is 96. Okay. And that's going to be divided by 8. Now, when I go to deal with this, I'm going to have 5 plus or minus now the square root of negative 71 all over 8. Now, you might already see a situation taking place, or maybe you don't. That's okay. But this radical is going to give me some problems. This radical is what we call undefined. And it's undefined. We've talked about it a lot throughout the course. I cannot take the square root of a negative number. Right? If it's negative, that's a problem. So I can't take the square root of a negative number. There is no solution there. That doesn't exist. So when I see it in my quadratic formula, what that tells me is that this equation actually has no solution. So there is no value of x, there's no value for x that will make this equation true. Okay, so when you run into this situation, that's what's happening. So since the square root of negative 71 is undefined, or you could say something like it's not a real number, you know, since the square root of negative 71 is undefined. Or you could say since the square root of the square root of negative 71 is not a real number, therefore this equation has no real solutions. And it also, you could also say it has no real, so again, the word solutions and the word roots kind of, you can swap in and out. So you could say this equation has no real roots either. Okay.